Kia ora koutou katoa, it's Mrs. Goodson here, and this video is about the structure and bonding of ionic compounds. So that's compounds made of positive ions and negative ions. So the learning outcome for this video is to be able to describe the structure and bonding of ionic compounds. The compounds are different to elements. They are often more stable and they come from the elements, and they are more stable than the elements they originated from. They may release this extra energy in the form of heat or light when bonding together. So there are two main types of bonding holding atoms together in a compound: ionic bonding and covalent bonding. A compound is a metal formed by chemically bonding two or more chemical elements. So in this video, we're going to look just at ionic bonding in ionic compounds. Ionic bonding is where one atom completely takes valence electrons from another to form ions, and the resulting negative and positive ions hold together with electrostatic attraction. This is the attraction between positives and negatives. This type of bonding occurs when a metal and a non-metal react and there is a transfer of electrons. So the electrons that are going to transfer are our valence electrons, those ones on the outside of an atom. The ions then combine in a set ratio to form a neutral compound with negative and positive charges balanced out. So this is important. Overall, ionic compounds have no charge. So you can have the electron transfer between a metal atom and a non-metal atom, and then you end up with a positive ion and a negative ion. So the positive ions are on the left side of the table, and so they're all our metals that are going to form positive ions, and all our non-metals are going to have negative valence because they gain electrons to form negative ions, whereas metals, these are all metals on this side, they lose electrons to form positive ions. Monatomic, mon just means one. So these are ions with single atoms, all right? So like sodium. Di means two. So diatomic ions have two different atoms. Like this hydroxide is a combination of oxygen atoms and hydrogen atoms, and overall it's got a charge of -1. So here are some examples of polyatomic ions. That means many ions. Poly means many. So we've got ammonia, hydroxide. This has a charge of +1, minus. This is minus. This is 2 minus, 2 minus, and 3 minus. So these are all ions, polyatomic ions. Now these metals in the middle of the periodic table, these ones all in the middle, not calcium. These ones in the middle are called transition metals, okay? And they can have different valences. So we've got like iron, the metal, has iron 2 plus and iron 3 plus. Copper can be copper 1 plus, but the one we usually deal with is the copper 2 plus. So a lot of them are 2 plus. They've lost 2 electrons to form stable ions. So these ones in the middle are called transition ions, and they're really common metals that you would have heard of, like copper and zinc, and silver and gold and iron and others. Okay. So chemical bonding is what holds together compounds. Atoms which do not have a complete valence shell are unstable, so they have to join up with other atoms to get stability. So they can lose electrons, they can gain electrons, or they could share electrons. And in another video, we're going to talk about sharing electrons and covalent bonding. But in this video, we're talking about ionic bonding. So this little sodium atom says, I have an extra one here, you can take it. And chlorine says, I only have 17 electrons. I feel so much better if I had one more. So sodium kindly gives her electron to chloride, and that bonds them together, and the sodium becomes positive. Okay, so ionic bonding is when a metal atom gives its electron, one or more, to a non-metal atom. Okay, so you can always spot ionic bonding because it's got a metal and a non-metal. So this electron transfer, so this is magnesium, it's losing 2 electrons and it gives it to the fluorine atom. It's 1 to this fluorine atom and 1 to this fluorine atom. So the ratio of this is going to be 1 to 2. Okay, so 1 magnesium atom will bond with 2 fluorine atoms to make fluoride ions and magnesium ions. So that's where you get the ratios. If this is a ratio, So this holds it together, this bonding between the positive, this attraction between the positive ions and the negative ions. So we've got cations are the positive ones and anions are the negative ones. We always have cations and anions. So they both become stable and they have a strong attraction to each other. So you have to remember this is strong bonding, okay? So the way we name this, we take the sodium and the hydroxide. So this is our positive ion and this is our anion. And always do the metal or the positive cation first. So here's some examples. We've got sodium chloride. So we've got a sodium ion and a chloride ion. So the overall it's got to be neutral. So we have a ratio of 1 to 1, and we don't bother to write the ones, but that's 1. We don't bother to write the charges because they cancel out. So we've got sodium chloride. What if it's a 3 plus cation and a 1 negative anion? So then it would be a ratio of 1 aluminium ion and 3 chloride ions. So we've got a ratio of 1 to 3, and we write it like this. Another example is aluminium oxide. That should be an oxide. We've got an oxide, it's a 2 minus. So then we get a ratio of 2 aluminium, which is 6 plus, and 3 oxides, it can make 6 minus to make it cancel. So this one is the most difficult it gets. We get a ratio of 2 to 3. So a way we can write it down is we always write the cation first, and then we write the anion. We drop the charges so we can remove any brackets unless we need them. And then we get the compound. So this video has been about describing the nature of the ionic bond, which is a strong electrostatic force between ions, okay? And then we can describe the structure of solid ionic substances, write the chemical formula for ionic compounds, and be able to justify the ratio of positive to negative ions. So this video has been all about ionic bonding, ionic structure, and writing the formula for ionic compounds.